This is Unit 1 Kinematics, the very first unit of AP Physics 1. So, mechanics is about study of motion, and kinematics is the fundamental of mechanics. In kinematics, we learn everything about the motion. We learn how an object moves in a certain way. We learn if an object is moving along a straight line or if it's moving along a circular path, if it's going through projectile motion, if it's moving up and down in a straight line. We also learn if an object speeds up or slows down and all of that. So let's get started. So let's start from scalars and vectors. Any physics quantity would be either a scalar quantity or a vector quantity. A scalar quantity has magnitude only. Think of when it comes to measuring height. Your height would be something like 5'5", 5'10", 6'2". All of these are magnitude. None of these have direction. So there's no such thing as Peter is 5'10" upward or 5'10" downward or to the left or to the right, due north, due south. It does not come with a direction. There is only the number plus units. That's what we call as magnitude. And temperature is also magnitude. 37 Celsius degree or let's say 80 Fahrenheit degree. All of these come with number plus units only without any direction. So temperature and length, width, height, and energy. All of these are considered magnitude. On the other hand, some of the physics quantities come with direction too. So let's imagine that you are pushing something really hard. Okay, really hard, that means that the magnitude of the force would be quite large. And pushing means that you are applying a force away from yourself. So there is a direction. Pulling means that the direction of the force is toward yourself. So pushing, pulling, all of these refer to force, which is a vector quantity that comes with both magnitude and direction. And velocities and accelerations are also physics quantities that are vectors. They come with magnitude and direction all the time. So if you have two vectors quantities, one is pointing to the right with 2 units, one is pointing to the left with 2 units. They are two different vector quantities. They are not equal to each other, even though they have the same magnitude. In some cases, a scalar quantity is the magnitude of a vector quantity related to it. So, for example, velocity versus speed. So, speed only refers to magnitude, so it's a scalar quantity, while velocity is a vector quantity. So, sometimes instantaneous velocity, for example, 5 meters per second downward, well, for this velocity quantity, it has the magnitude which is equal to the speed, 5 meters per second. But this is not always the case. Sometimes a scalar quantity is not the magnitude of a vector quantity related to it. For example, now we can compare distance to displacement. So this is the starting position, and this is the ending position. And then I'm going to move along this path, this yellow path. Well, then the total length of this yellow line would be distance. Okay. On the other hand, for displacement, we measure it by connecting starting point and ending point directly using a straight line or a line segment, and then by adding an arrow from start to the end. So the magnitude of the displacement would be the length of this green line segment. And obviously, this green line and yellow line segment have two different lengths. So in this case, the displacement, the magnitude of displacement is not equal to the distance. So we need to be very careful when we compare the magnitude of a vector quantity to a scalar quantity. Also, some students might think that a scalar quantity is always a positive or a zero because it's magnitude. And when it comes to magnitude, you might only think of the length or width or height. So those are the values that are always positive or zero. let's say 3 meters long, 5 feet, or 100 square feet. Okay, but actually, a scalar quantity can be negative. A scalar quantity can be positive, it can be negative, or zero. And the best counterexample would be temperature. So, when it comes to temperature, and if we are measuring the temperature using Celsius degree, then we all know that 0 Celsius degree and 100 Celsius degree are two important temperatures, where water freezes and where water boils. But obviously, the temperature can goes below 0 Celsius degree. Let's say in winter in South Korea, it can easily go to -10 Celsius degree, which is pretty cold. So even though it comes with a negative sign, but still it's only magnitude. It's not -10 downward or due north or east, or whatever. It does not come with a direction. So -10 by itself represent a magnitude. So let's do a quick quiz to make sure that you understood what I just explained. Okay, question number one. This is a pretty easy question. True or false? Okay, work is a physics quantity. Work is a physics quantity that you will learn in unit three. Okay, it can be positive or negative. The unit for work is joules. It can be positive 400 joules. It could also be negative 400 joules. This means that work is a vector. True or false? So the answer is it's false. Work is not a vector. Work is a scalar quantity. So just like temperature, um, work is a scalar quantity that could be both positive or negative or even zero. Okay, here's another question, another true or false question. Distance is a scalar quantity while displacement is a vector quantity. So magnitude of a displacement is the distance. Well, I think not all of you knows the answer. So again, there are 2 points, initial point and final point. Okay. Let's say I'm gonna follow this path to go from point A to B. Then the length of this red line segment would be distance, while for displacement, it will be represented by a straight line from A to B. So the magnitude of the displacement would be this blue line, while the distance is the red line. So obviously, they are not the same. Again, the answer is false. And next, um, I walk along the following paths to go from A to B. This path is a vector. Okay, so this time I added the path. I drew out the path. Also, I added an arrow. And the answer is false. I mean, even though there is an arrow, this is not a vector. So, what we mean by vector is it comes with a magnitude and direction. Okay. And when I say magnitude, it needs to be represented by the length of the arrow. So, it needs to be a straight line from initial point to a final point. So, it's as simple as just connecting these 2 points and then adding an arrow to represent the direction. So if you draw out the whole path that it followed, that's not a vector. For vector, it will be always a straight line between 2 points with a direction. Next, let's talk about representation of vector. In math, a vector can be represented as a matrix, usually using a column vector. So, for example, for this example, for this vector called D, it starts from point A and it goes all the way to point B. Okay, so for this vector, we gain this vector by moving from point A to the right by 1, 2, 3, 4, 5 units to the right, and by moving up by 2 units up. So in math, we use the column vector 5, 2 to represent that we move along x-axis by 5 units to the right, and we move along y-axis by 2 units upward. Okay. But in AP Physics 1, we do not use matrix. It's going to get way too complicated. So there are two ways to represent vectors in AP Physics 1. One is magnitude plus direction. So in AP Physics 1, there are two ways to represent a vector. One is by magnitude plus direction. So for example, 5 units um, towards 45-degree above x-axis, or let's say 3 kilometers due north, or something like 10 units towards negative y-axis. All of these are magnitude plus direction. Or we can make it as simple as plus minus sign plus magnitude. And now remember that the simplified version, plus minus sign plus magnitude, can only be used when there are two directions, which means this can only be used in one dimensional motion. It can only be used in one dimension. And the reason is because in one dimension, there is always only two directions. For example, along horizontal axis, there are only two directions. One is to the right, positive x-axis. One is to the left, negative x-axis. Then in such case, then you can claim that, okay, this is positive 5, a vector of positive 5, while this is a vector of negative 5. So along one single line, positive sign and negative sign is enough to represent direction. But if it's two dimension, then you need to be more specific. If it's two dimension, let's say there is both x-axis, then y-axis, then you can't just say, oh, 5 units, top right corner. That's not very specific. We need to say 5 units towards a very specific direction. And the vector notation would be either the letter and then with an arrow on top of that, or boldface. But if you're handwriting, it does not really matter, and you can just use a letter to represent it. Okay, so in two dimension, to make it more clear, there's something called x component and y component. And remember that in math, we use column vector 5, 2 to represent this vector d, which means that we move to the right by 5 units and we move up by 2 units. That's exactly what we call as the x component and y component. Okay. So we always set up this XY coordinate in two-dimensional in physics, and we can break down the vector into by how many units it moves to towards x-axis, and by how many units it moves towards y-axis. So x component is positive 5 and y component is 2 in this case. Oh, what if it moves from point B back to A? If it's moving back from point B back to A, then in this case, the x component would be equal to negative 5, which means it moves to the left. Okay. And the y component would be negative 2. Again, this means that moves down by 2 units along y axis. So x component and y component can be negative values. Okay. And to actually find that x component and y component of a vector, we need to use trigonometry. We need to use sine, cosine, tangent. And you need to be familiar with hypotenuse, adjacent, opposite. Okay. So here you see this triangle. Okay. So we have a vector called f pointing to the right top corner. And at the tail of this vector, we're going to set that as origin 0. And that's where x and y axis meet. X and y axis meet at the origin. Okay. And then what we're going to do is we are going to start from the tip of this vector f. And then we are going to draw a line towards the x axis. Okay. And this line shouldn't be slanted. Okay. Okay. This line should meet x-axis at exactly 90 degree. So it's going to form a right angle here. Okay. Then now we have this right triangle here. Okay. And you know that for right triangle, we can apply sine, cosine, tangents. Okay. So now the magnitude of this vector is called f. Okay. Then it's the hypotenuse. And then its x component, let's call it fx. Okay, that's the x component, is adjacent when we consider this angle theta. Then we know that cosine theta is adjacent over hypotenuse, so f of x over f. If we rewrite this equation by moving f to the other side of the equation, then we get that f times cos theta is equal to f of x. And this is how we get the very first equation here, which represent the x component of any vector. X component of any vector would be the magnitude of the vector, aka the length of the vector, multiplied by cosine theta. And again, here this f represents magnitude. And we can find the y component of the vector with similar method. So this time, from the tip of this vector f, I'm going to draw a line towards y-axis. And again, here we need to form a right angle. Okay, then this time we have another right triangle up here. Okay, this is a right angle. This is right angle. This is right angle. This is right angle where x and y axis meet. Okay, that basically means that this is a rectangle. Okay, and then we know that for rectangle, that means that two opposite sides are parallel to each other and also they are of equal lengths. So this means that this part, which is fy, y component of this vector f, is actually the same as this part. Okay. And then again, let's take a look at this triangle, this right triangle. For this right triangle, again, considering angle theta here, fy, the y component, is opposite. So now we have sine theta is equal to opposite over hypotenuse, so fy over f. Again, I'm going to move f to the other side of the equation by multiplying it. Then I get f times sine theta is equal to fy. And this is the equation that represents the y component of a vector. And how do I get the third equation of fy over fx is equal to tangent? Well, now it's very obvious. On this right triangle, it's obvious that fx is adjacent, fy is opposite. So opposite over adjacent, fy over fx is equal to tangent theta. Okay. And now let's talk about how we can find that angle theta. So instead of saying the right top corner or northeast or southwest, we want to be very specific about the direction when it comes to physics. And in physics, direction of a vector is often represented using north, east, south, west, or by referring to x-axis or y-axis. Okay, so here's an example. I recently traveled to San Francisco, and here is LA where I live, and here is San Francisco on the map. Okay, so now let's assume that this airplane flies directly from LA to San Francisco along a straight line. Okay, then now this is a vector. And instead of saying that, oh, flying from LA to San Francisco, I want to use angle to represent it. Okay, I also don't want to make it very ambiguous, saying that, oh, let's fly towards northwest or let's fly towards the left top corner. We want to make it very specific. Okay, so here, what I'm going to do is first off, I will try to set up the coordinate axis. I'm going to label um, north, east, south, west. Okay. So the angle between this vector and north is around 32 degree. This is around 32 degree. Okay. Then how we can refer to this direction of a vector would be 32 degree west of north. This means that north, whichever direction that comes after of, is the reference direction, okay? And starting from north, I'm going to move towards west by 32 degrees. So this is north direction. And then from north, I'm going to move slightly towards west by 32 degrees. So now this is the direction that I'm pointing at. This is not the only way for me to refer to the direction. I could also calculate this angle. Well, we know that east west and north south should cross at 90 degree. This is 90 degree here. So this purple angle should be 90 degree minus 32, which is 58 degree. So this time I could take west direction west as my reference and then move towards north by 58 degree. So this vector, the same vector, has a direction of 58 degree north of west. And these two refer to exactly the same direction. Okay, this is how we refer to direction of a vector in physics. We could also use x-axis or y-axis. Usually we take the horizontal line as x-axis and then we take the right side as positive. So if this is the vector that I'm talking about, and this is 32 degree, okay, and this is 58 degree, then we can say that this vector points at the direction that is 58 degree above negative x-axis. And this means that I'm going to take negative x-axis horizontally to the left as a reference frame, and then I'm going to move above that, which is in the clockwise direction by 58 degree. Well, I could also refer to positive x-axis. I can calculate this angle, which is 90 plus 32, so 122 degree. And I can claim that this vector points in the direction of 122 degree above positive x-axis. So again, these two will refer to the same direction. And this is how we talk about direction in physics. Again, we want to be very specific about direction. Now let's do a quick quiz to make sure that you've fully understood what I just explained. Which of the following represent the same direction? So here we have 6 different directions, and obviously all of them are represented using um, north, east, south, west. So first off, I'm going to draw 4 directions. I'm going to draw a coordinate with 4 directions labeled. And let's take a look at, let's label all these directions one by one on this coordinate. Okay, the first one is 20 degree east of south. This means that I'm going to start from south and I'm going to move towards east by 20 degree. So this is south and I'm going to move towards east by 20 degree, which will be this direction. So I'm going to label this as direction number 1. And direction number 2 is 20 degrees south of east. Again, that means starting from east and move towards south by 20 degrees. So east, move towards south by 20 degrees. So it will be this direction. This is direction number 2. And direction number 3, 20 degree west of north. This means that I'm going to point at north first and move towards west by 20 degrees. So north and points toward west by 20. So it should be this direction, direction number 3. And the next one, direction number 4, that's 70 degree west of north. Again, that will be pointing north first and move towards west by 70 degrees. So remember this was 20 degree. So this time I need to move by 70 degree instead, which will be way, way more towards west. So this is direction number 4. And then number 5, 70 degree west of south. Okay. So let's point towards south first and move towards west by 70 degree. Then it will be this way. So up until now, we have five directions on this coordinate, and none of them is of the same direction. That means the last one must be of the same direction with one of these five. So the very last one, direction number six, 70 degrees south of east. So let's point toward east first and then move towards south. So this is east. And then now let's move toward south by 70 degree. Okay. Then it should be pointing at this direction. So it's obvious that direction number one and six are of the same direction. So this one and this one, they are pointing at the same direction. So you should be able to label the direction of all of these six directions on this four direction coordinate. And next, we have another question. And this time it asks which of the following represent opposite directions instead of the same direction. And we are given four directions. And this time, instead of referring to directions using north, east, south, west, it's using positive x axis and negative x axis as reference. So this time, what I'm going to do is I will try to draw out x axis and y axis first. Okay, direction number one. It says 45-degree below positive x-axis. That means, okay, I'm going to take positive x-axis as my reference, and then I'm going to go below that, which means I'm going to go to quarter number four. So this would be my direction number one. Okay, and direction number two, 45-degree below negative x-axis. So negative x-axis is right here. Going below that means this direction will be in quadrant 3. This is direction number 2. Okay. And then I have direction number 3, 45-degree above positive x-axis. So starting from positive axis, go above that. Okay, so it will be in quadrant number 1. And direction number 4, 45-degree above negative x-axis. This would be in this direction. Okay. So now it's obvious that 4 and 1 point away from each other and they are on the same line, so they are opposite directions. And direction 2 and 3 are opposite directions. So these two are a pair that points at opposite direction, and these two are a pair that points at opposite directions. 1 and 4 and 2 and 3. The next question. Find the x component and y component of a vector of 15 units long and pointing at 30-degree below positive x-axis. So again, it refers to direction using x-axis. So again, I need to draw the xy coordinate. And this vector is pointing at 30-degree below positive x-axis. So this is 30-degree. And we need to find x component and y component. So again, what we need to do is we need to start from the tail. We need to start from the tip of this vector, and then we need to draw a line towards x-axis and form a right angle right there. And we need to find the lengths of this much and this much. So again, we can use sine, cosine. We can use trigonometry to figure that out. So this side should be 15 multiplied by cos 30, which is 15 over 2 square root of 3. And this side should be 15 times sine 30, which is 15 over 2. But that's not the final answer yet. Now you notice that this vector is pointing at an angle 30-degree below x-axis. It's pointing towards the right bottom corner. So this means that its y component must be a negative value. The reason that you get a positive value instead is because you plug in 30 degree, you plug in positive 30 degree in sine instead of negative 30 degree. So if you've taken trigonometry or pre-calculus, then you know that in unit circle, the way we measure the angle would be from positive x-axis and in the counterclockwise direction. So from positive x-axis all the way to this vector, that is actually the corresponding angle for this vector, which is 330 degree, or we can use negative 30 degree to represent it. And if you plug in negative 30 degree instead to get 15 times cosine negative 30 degree, then you will still get a positive value for x component. But for y component, sine negative 30 degree gives you a negative value. So it's negative 15/2. The problem is AP Physics 1 is a course that requires only Algebra 2. So it does not require you to have full understanding on this trigonometry or pre-calculus. So the easier way to understand this would be just try to find the length along x-axis and y-axis, and then we're going to add the positive or negative sign based on its direction. Okay, so now we know that the magnitude would be these two. And now let's take a look at the direction. The direction is the right bottom corner. So first off, it's moving towards right. Okay, so along x-axis, right represents positive value. So that's why its x component would be positive 15/2 square root of 3. While for um, right bottom corner, bottom or downward represent negative because upward represent positive y-axis. So that's why for y component, we need to add a negative sign and it's negative 15/2. So these two represent x component and y component of this vector. And next, we have another question. This time, you are given x component and y component, and you need to find the magnitude and direction. This time, you are given x component and y component, and you need to find the magnitude and direction of this vector. We can use Pythagorean theorem to find the length of this vector or the magnitude of this vector. So remember that for x component and y component, they're perpendicular to each other. So this is a right triangle. So we can write an equation of magnitude d squared is equal to 2 squared plus 1 squared, which is equal to 5. D is equal to square root of 5. Okay, that is the magnitude. And now we need to find this angle theta. So given that we already have x component and y components, and tangent theta would be equal to y components over x components. And using arctangent, we can find that theta is approximately 22.5 degrees. But you can't just leave the answer as 22.5 degree. That does not really tell me a very specific direction. So I need to add more. I need to add more details. So in this case, it would be 22.5 degree above positive x axis. So this is the direction, and this is the magnitude. So that's day one of AP Physics 1. If you find this video helpful, please subscribe to my channel and like this video.